This video is Test for Independence, the chi-squared distribution, part 2. We're beginning with example 2, educational issues and museums. Do people who are interested in educational issues visit museums more often than people who are not? In 2008, the General Social Survey asked 1,499 people how interested they were in educational issues and how often they had visited a science museum in the past year. The following table presents the results. Can you conclude that the number of visits to a science museum is related to interest in educational issues? Use significance level equal 0.01. When they say, can you conclude that the number of visits to a science museum is related to interest in educational issues, that means, are the number of visits to a science museum and interest in educational issues, are they independent or dependent? So if they're related, they're dependent. That's what that means. So for our null, we will write educational interest and number of museum visits are independent. Remember, you take the first factor, educational interest, and the second factor, number of museum visits, and you say are independent for the null. So for the alternate statement, educational interest and number of museum visits are dependent. You could also say are not independent, as we did in the last video, but I just wanted to write it a little bit different just to show you the different ways that you could write it. You could also say that the educational interest and number of museum visits are related. Okay, so now we're going to pull out the calculator, or pull up the calculator. And this is there are 3 rows and there are 3 columns, so it's a 3 by 3. So we're going to go to seconds, matrix. We're going to go to edit, hit enter. When we choose matrix A and then make it a 3 by 3, we already have something in there, but that's okay. You just type over it. 512. And then 138, 58, 460, 98, 34, 163, 2114. So just want to check real quick to make sure that I have all the numbers incorrectly. And I believe I do, so now we're going to run the test. Stat, tests, chi-squared test. Just go to calculate. And we get 0.0134. 0.0134. So 0.0134 is actually greater than 0.01, so we fail to reject the null. So that means we don't have enough evidence to support the claim that they are related. Now, remember, you cannot accept the null. You can reject the null in favor of the alternative statement, but we cannot accept the null. We can't say that educational interest and number of museum visits are independent. What we can say is there's not enough evidence to conclude that educational interest and number of museum visits are dependent. Or we could say we do not have enough evidence to conclude that number of museum visits and educational issues, interest in educational issues, are related. You could also say that. So we cannot conclude that the number of museum visits and interest in educational issues are related. Didn't have a lot of space there. All right. Example 3. Test to see if anxiety level and need to succeed in school are independent. So even though you're testing to see if they're independent, your null is still going to say independent and your alternate statement is still going to say dependent or not independent. And at the end, when we make our conclusion, you can either say that there's enough evidence to show that they are not independent, or there's not enough evidence to show that they are not independent. We cannot say that they are independent because that would be the null, and again, we can't accept the null. Okay, so pause the video and see if you can complete this one, and then come back when you're ready, and I will let you know what the answer is. Okay, so for the null, we write anxiety level and need to succeed in school are independent. The alternate is anxiety level and need to succeed in school are not independent. It was a 3-row by 5 columns, so I did a 3 by 5 in the matrix and put these numbers in. My p-value was 8.2 e to the negative 8, which rounds to 0, which is less than 0.05, so we reject the null. If we reject the null, that means we have enough evidence to support the claim. So our conclusion is actually the alternate statement. Anxiety level and need to succeed in school are not independent. And actually the claim was that they were independent. So it's not enough evidence to support the claim, but it's enough evidence to support the alternate statement. So you would need to say this right here for the conclusion. All right, one more. Volunteering in a volunteer group, adults 21 and older volunteer from 1 to 9 hours each week to spend time with a disabled senior citizen. The program recruits among community college students, 4-year college students, and non-students. Is the number of hours volunteered independent of the type of volunteer? Use 0.05 significance level. So looks like this will be a 3 by 3, but pause the video and come back after you're finished working through the problem and check your answer. Okay, so for the null, I put the number of hours volunteered and volunteer type are independent. For the alternate statement, number of hours volunteered and volunteer type are not independent. It was a 3 by 3 matrix. The p-value for the chi-squared test was 0.0113, which is less than 0.05, so we reject the null. So the number of hours volunteered and volunteer type are not independent because we rejected that right there. So that meant the alternate statement had to be true. Okay, so that's actually the last example. But before we end this lesson, I wanted to show you the calculator how to find the expected values. Okay, so if I turn this back on, I had just run a chi-squared test. This was from, I think, maybe example 6 or 7, I can't remember. But we had entered data into the matrix. We went to edit, and we'd made a 3 by 3. And then we went stat, calc, chi-squared test, and then we calculated. All right, we made our decision, wrote our conclusion. All of that's fine, but what I want to show you is how to get back to the expected values, because in your homework you will be asked what was the expected value, because these values here on the screen, these kind of values here, these are the observed values. What are the expected values if the data really was independent? So to get there, you're going to go back to your matrix, second x to the negative 1. You're going to go back to edit, but what you're going to notice is there is a B matrix here that you didn't enter, but it's there because the calculator created it for you. So go to number 2 and hit enter. Make sure you have edit highlighted. And these are the expected values. Now these are not the expected values from example 4. This is from an earlier example, but you can see them. So if the homework asks you for expected values, go after you run the test. It won't be there before you run your test. After you run your test, go to second x to the negative 1, choose edit, and go to matrix B, and you will find your expected values. Okay, you guys. That is it. We are finished. So if you have any questions at all, please let me know. All right.